So hello guys, a nice quiet cozy company over here. I would have gone to the other lecture myself if I was outside, but what I'm going to talk about is it's an integrated modular programming language. The whole objective is to try and see if you can, is about end user programmability. So I'm Saif. I'm actually a doctor. I'm not a proper developer or anything like that, but I do have interest in robotics and tissue engineering, and which is what I use Perl for. So I also developed Guide Fate. I don't know if anybody have seen that, but that's a way of designing GUI interfaces which are platform independent in Perl, and this was part of an attempt at trying to get a robotic control which is programmable. So essentially, I would divide programmers, and I was always been into certain categories and the users into certain categories. I was always a selfish developer. I wrote programs for myself, for my own little projects, for my own needs, yeah, and it helped nobody else, just for me. And I knew what it did, and I knew how to control it, and I knew what its intricacies. Then are there other developers who try and make their programs work for other people. And the users also can be divided into a couple of groups. They can be the demanding users. They just want a program that does what they want it to do. They have no desire in any other use cases, just what they need. And the other ones, they like things to work exactly right, and if they don't, they're unhappy. And then there's an inquisitive user who says, here's a tool, and I want to be able to make it do what I want it to do. I will adapt it for my needs. So basically, if you combine the two good people in this group, you want to develop a program which offers the user an ability to configure it to their needs. Yeah? And what I'm interested in is not just configuring it, but also for the non-developer user to create programs out of the application that they've suddenly come to use as find useful. So basically, what I want to do is develop a way of allowing anybody to program any language, which corresponds to their domain of interest. So this programmability can be ported from one system, one application to another. So basically, I'll go through a few things. I'll describe what my goals are in trying to get this off the ground. I will describe how a scripting language works, or at least how I think it works. I'll describe the basic core programming commands which are in Simple, and I'll describe how to make it modular. Then I will give you a couple of examples and a couple of projects I'm working on. Then I want to ask, does this actually make sense? Does this actually make sense to what do you think it's a useful thing that I should do? Should I do something else? And then I'll make a conclusion of some description, and you can agree or disagree with that. So the context is this. So as I say, one of my interests is tissue engineering, and tissue engineering is about building organs, building tissues, building living things, and I develop bioprinters essentially. So if I imagine that I'm going to develop this tool and I want somebody else to use it, they need to be able to. They're not going to be developers. They're going to be ordinary non-developer users. Yeah? So what I need to do is give them a little user interface that they can interact with, which is user-friendly. I'm going to allow them to program this device, which my application will be able to render into a image that they can say, yes, this is the goal I want to achieve, and then I'm going to ask the computer to drive a device, a printer of some description that will produce the image that the user thinks he's going to create. And I want the user to be able to decide the program that he wants to run in the in the device. So lots of things exist that are programmable for ordinary users, non-developer users. But so I want to make this object, this structure simple, so anybody who's not a developer can use simple paradigms to decide how a program works. Another reason for me doing it is I developed GuideFate. GuideFate is a GUI design tool, and I wanted to have a easy way for a platform-independent widget creation in Perl. And at the same time, I don't want it to be useful just for my needs. I need it to be useful for other people who might want to use it for their needs, because they might have other ideas that they might want to use. So, and also I want to be able to computers to generate the code. If computers can generate the code automatically, it means that I can actually extend the make it more intelligent use of my devices. So does it make sense to use an interpreted language to interpret another language that you've created yourself? Certainly Perl, if you're going to do it in any language, you're going to use Perl. Perl is it parses, it transforms data, and you can as I learned Perl, and in fact I'll be honest, it's the only language I know, and but I find ways that Perl allows you to do this quite easily. So there are Perl script interpreters already. I mean, you can do a bit of basic programming and scheme and OCaml. They're for me, they appear complicated. So I want simplicity. I want it to be able to integrate to whatever application that I want to do, and I want modularity. I want to be able to plug in things to it so that I can extend that language that I have. And this has been sort of done before. I mean, most things that we do, I mean, if you use NuPlot or ImageMagick or Festival, these are scripted languages, scripting tools, and each of these have a different language. If you want to go from one device, one application to another application, you have to learn another language altogether. And that does make things a little bit complicated. The syntax is different. So what I want to do is separate the core from the actual function. So this is an application that I made some time ago, which was to allow a programmer to program a Raspberry Pi to control the input-output GPIO pins and the I2C interfaces. So, and it was really using BASIC, but again, a single use case for the controlling Pi's GPIO. So I took that application and I took out the core of it. So and developed SIMPLE. SIMPLE stands for the Simple Integrated Modular Programming Language Experiment. It's like a backronym that is popular in developer worlds. But the objective is this: to try and get so what our interpreter would have to do is to extract a sequence of commands that you might give it in a script, extract from it the flow control, extract it from the code blocks and subroutines. It has to be able to handle variables and expressions. It has to handle inputs and outputs. And of course, it has to be extendable, as we said. So your application, which can do, say, control a robot. The user generates a script that will control that robot. The application runs it, and you get a yield from that. So what I've decided, I mean, one of the most useful learning tools I had was written about 30 years ago, was by Dr. Ian Logan. I don't know if you've ever heard of a ZX Spectrum. ZX Spectrum was an old device, and he wrote a book called The Complete Spectrum ROM Disassembly. So in 8 kilobytes, you have an entire display manager, an operating system, and an interpreter, and an expression evaluator, all contained in 8 kilobytes. So I'm sort of using that paradigm, what they decided to do to try and develop my program. So we have a preprocessor which rationalizes statement boundaries decides whether a colon or a line end decides the boundaries. It includes other code from other sides. It extends the module as needed, converts and folds the code. So by code folding, I mean it sorts out the brackets and the blocks within the code to have a flow that it can sort of parse easily. Then a parser takes a pointer, like in a program counter pointer, goes through one command block to the next command block to the next command block, and if it is a block, it executes a block because it enters a block and then executes the content of the block. If it's a statement, then it executes a statement. And then there is a way of executing statements. So basically, it extracts from each line, each command you've got, the command itself, and the parameters. And it decides whether the command is a flow control command. By flow control, if, when, while, whenever, go sub, all these things. And then there is then decides, is this a command, a built-in command? I'll execute the built-in command. If it's not, I'm going to look for look to the commands that are in my extensions, and then I'll execute that command. And if a command is not found, all it says is it logs it, but ignores commands it doesn't find. And also in all this, you also have to have an expression evaluator. So basically, your computer program is going to do some mathematical analysis. So you have to have a little something to interpret expressions. So the core functions are limited. And the whole purpose of this is to have things. The actual core, all it does is runs the program as if it were, and it will run without any extensions, but it will do nothing apart from print. So you can include code from other files. You can exclude commands. Exclude works on, so basically if you have an extension but you want to borrow, say, a print from one extension but not from another extension, you can exclude files, and you can of course extend that program itself. And there are commands, and there are very few commands that are built in. Let, print, pop and push. In fact, let is sort of assumed if you've got it's not necessary, but it's there. And go sub also is assumed if it's not there. And then the flow control commands: if, else, else if, while, for, repeat, sub until, and then whenever, when, forever, after. When the timer component of this is built in, so we can let somebody say, when this happens, do this function. So it'll be a little that allows a little bit of things, and then some mathematical expressions. Basic ones are included. So and then we have extensions. Extensions add the domain-specific functionality that you want to achieve. They have their own internal variables. They have their own routines, and so basically what happens is that I can make the same core apply to various things, to robotic control, to application control, game development. I just add extensions to the core, and so I would create a environment. My sim test is an environment for Simple to run in, and I extend that environment using another extension like logo. You can also load the extension from within the code itself. If you have an extension, if you have a line in the code which says extension logo, it'll load the extension logo, the logo extension in there. And the structure of an extension that I'm doing, and this is what I'm not sure is the right thing or not. What I'm doing is I'm making the extension formatted like the contents of a hash. It has a selection of variables that are internal to the application, for that extension, and a selection of commands which are all parts of all hash references to subroutines. So, and if that command exists, it knows to execute that hash reference inside. Yeah, and it loads the extension this way. It does this do the file that you want, the file that actually contains the extension. And then for each key in that extension, each variable, logo, vars, command, whatever, it extends, it collects a repository of extensions within your code and extends that for you. So shallow copies the contents of the hash into the extensions, xnem, yeah? Missing bracket there. And then it logs the extensions loaded. By doing it this way, I can tell that I can record log a successful loading of the extension. So best way of describing this is to just do an example. An example that I've made is to use turtle graphics. Turtle graphics is I'm sure you know, you can create graphical applications. What I've done is this, that here's a script that this program can parse. And I'll do a demo of that if there is time, of how simple logo works. You allow it to set up, it allows comments, which are ignored, obviously. It allows variable assignments. It allows, these are domain-specific commands for the logo. You clear the screen and you center your turtle in the middle of the screen. Repeat 40 times. That's one of the core functions. And I'm going to say HELLO, and HELLO are subroutines that are in there. So it does HELLO 40 times, and it does each of those things. Each of these commands, sub H, is logo like it says left 90, forward 10 times F, and then back 5 times F. So it evaluates that expression and puts those right 90 forward, and this draws an H, and you'll have similar functions for E, L, and O, and the next position to go to the next cursor position. So these are subroutines that are divided by the script writer. These are the red ones are the actual domain-specific commands, and the dark blue ones are included in the core. So, and this will produce this kind of result, yeah? So you can create a drawing which is a spiral of hellos going up, and it produces a valid SVG file. And so basically, it's with very few functions, you've created a way of creating a complex a script, right? This logo script is interpreted by Simple and its extension, and presented on a display. And the same thing can be used. In fact, my initial aim was to try and do the entire presentation using a script. It took my brain a bit more. But this is essentially how it works. So there's a main application, has its programmability. It has internal scripts and external scripts. Programmatically generated, so programs itself can generate scripts. And end user, the key thing is the end user can create scripts as well. And the script is a script loads the extension and runs the user's commands within that application. So one of the things I wanted to do was I wanted to write a simple program. Perl arguably may be a bit difficult to learn. I wanted to make a scratch for Perl. So I wanted to have a little way of incorporating simple programming paradigms, flow control, subroutine definition, variables and expression handling, code folding, all within for newbies. Obviously, I'm a tissue engineer. I want to try and build a 3D printer. I want the robotic control to be scriptable to allow me to do this. I want to have customizable monitor and react utilities. So basically, you can say programs which may control, say, the lighting in your house. You might say, if it's dark, turn the light on. Yeah, so those sort of things. And the games engine as well. And I'm working on for the last couple of months. I've been just working on a little games engine that I could program in. Ultimately, the whole purpose, my goal is to try and make things easy. I mean, you can do things very object-oriented, very, very complex, and I do want to make my scripts maybe very simple to use. So the question is, does this really make sense? Does it make sense that we could do everything we want to do in Perl? We don't need an interpreter to interpret another interpreted language. But this might make it easier for a non-developer end user. So and I think, I don't know if you guys agree that it might be useful or not, but I think for me it probably is. So basically, I want to make it possible to integrate programmability into any application you develop. You develop an application, you need to be able to make it programmable. I want to, so you're not repeating yourself. You're not developing a code for plotting a chart and then finding another script. So one core function is at least portable across multiple applications. So all I've done is taken the simple flow control structures, the expression evaluators, and put them into a module, which will then allow anybody else to develop a domain-specific functionality. I'm going to see if I can give you a little demo. It might not work, but I can try. This, it goes a bit haywire. So this is. Okay, let's try. So this is my simple logo. If I can work it out. Yeah. So this uses guide fate to produce my. Sorry, my mouse goes haywire for some reason or the other. But it allows me to draw applications from here. So and essentially I can create a simple program which does. Put in examples in here, so easy. So here it is. So guide fate, if you don't know, is a way of producing a GUI simply in Perl. It works across platforms. Across different programming paradigms, backends, WX, GTK, Qt. It sort of works in all these things. Let me zoom in. Good question. How do I zoom in? Yes. Well, this is actually not an application. It's an application written in Perl. So it's not a really. Yeah. How do I zoom in? Maybe I can reduce the resolution of this. Can I reduce it? Sorry. Yeah, maybe that's right. Maybe essentially, yeah. But yeah. So this is essentially what I won't go through. Essentially, it's a turtle program that goes back and forth and draws a star for you. And I really want to try and do things in. And this is a little application. Again, my games engine that I'm trying to develop over here. So yeah. Oh dear. So. It sort of detects collisions and surfaces and tries to create sprites so to allow me to have a little. Oh dear, it gets and essentially the games engine is supposedly mathematically, physically reasonably accurate. It's not really, but it, yeah. So my mouse is going haywire. Sorry about that. And there is. Sorry. Good question. Do I have examples? Not on my laptop, unfortunately. So, sorry about that. Thank you, guys. Any questions or time for break? Thank you.